Hello there, Des here again from GMIT Letterfrack with another of our SolidWorks tutorials. Now just before we start, if you'd like more information on the degree programs we offer in furniture design, wood technology or teacher education, then please see our Facebook or Twitter pages. So in this video we're going to run through how to model this speaker mesh. Now what makes this difficult is I want the pattern to appear realistic as it bends or appears to bend around the corner. Now the way I would typically do that would be to generate a sheet metal part and bend it after I've put the holes into it. But in this case I tried a number of different methods. I just couldn't get it to work. It seemed to be too complicated for a sheet metal part to bend it. So I've taken a different approach in this case. I'm going to use a combination of an extruded thin feature as well as a number of curve driven sketch patterns to generate the shape. So while I will draw the casing for the speaker, this is the main portion, the main goal of this video is to generate this shape here. Now I should say that the technique used to generate this shape can also be used to generate some quite complicated curved mesh coverings, but for the focus of this, to keep the video a little shorter, I'm just going to draw this first square simple mesh. So let's begin. So moving over to SolidWorks, I will begin by drawing a simple base or body to house this mesh. So I'm going to start a rectangle and set that to be 70 by 80. And I'll add another rectangle and just offset the top, bottom and left to be 8 millimeters. And I'll use the Trim Entities tool to trim out that line, which is surplus to requirements. So now I'll close the sketch and apply a simple extrusion, but that extrusion needs to be mid-plane. So let's change direction 1 from blind to mid-plane. And let's set the value to 270. Again, I'm making up these dimensions, but it's not the dimensions that are important, it's the procedure involved. So press the green tick. That's going to represent the body which will house the mesh. So what we'll do is now cut a groove out of this to hold the mesh. So to do that, I'm going to start a sketch of a line on this plane. And if I zoom in, I'm going to start and make sure I see that little yellow marker. That shows me that the line is either horizontal or vertical. So click there. Remember, we're not going to put the dimensions on now. We'll put those on in a moment. Place the line along there. Again, I'm looking for that yellow marker to show me that it's in alignment with the previous line. And go back this way a little. Tap Escape, which will then allow me to activate the Smart Dimension tool. And I want to set those lines to be 60 mil. That other one can also be 60. And this front line will be 260. And finally, I want an offset of 5 mil all the way around. So an offset there of 5 mil, an offset there of 5 mil, and I think we don't actually need the offset. The 260 will provide the 5 mil offset for us. So it's important to note that that black line that I've drawn actually goes into the back, this vertical portion of the plastic casing as well, and I want that. I want the mesh to bed 3 mil down into the base, 3 mil up into the top, and 3 mil back into the back. So I'll close that sketch. In fact, before I do so, I'll just put a fillet on the corners with a sketch fillet. Let's pick a radius of 5 mil, 5 mil, and 5 mil there. So press the green tick on the left to close the sketch fillet, and the green tick up here, or the close sketch up here to close the sketch. So let's now use that sketch to cut a groove into this base plate to house our bit of mesh. So to do that, let's go to Features, Extruded Cut. If you haven't done so already, you'll need to select Sketch 2. And what we want to do is tick this box that says Thin Feature, which will allow us to extrude a single line rather than a closed profile. So click Thin Feature, you'll get a preview, and there's a number of different settings that need to change over in the left hand side. So first of all, under direction 1, make sure it says blind, And let's change this 270 to 3 mil. That means the cut is going to go 3 mil down from that sketch. Under direction 2, you may need to expand it. If it doesn't say blind in this box, make sure you change that to blind. And now I can give it a value going up the way. So let's give that a value of 67. Now I've worked out those maths, and 67 means that it will actually go 3 mil up into the material at the top as well. Finally, mine happens to have guessed right, but the thickness of that groove may actually be 10 millimeters by default in your SolidWorks. So just make sure that's set to a single millimeter. And I want to make sure that the line that I've drawn, the sketch that I've drawn, is on the outside. You can see here the thin feature has actually happened outside of that sketch. So let's simply go and hit reverse, the reverse here in the thin feature, reverse direction. Now it jumps inside. So the sketch is there and all the cut happens inside that. So if we press the green tick, now what we have is a nice, neat groove ready to take the mesh. So here I am in a new part, and in this part I'm going to draw the mesh that will fit into the slot we've just created. So to do that, I'm going to start a new sketch on the top plane. I'm going to draw the sketch to resemble the shape I started the previous groove or the trench with. Let's dimension each of the sides to be 60 and this baseline to be 260, which are the same dimensions I used a while ago. I'll also call up a sketch fillet and tell each of the corners to have a radius of 5 mil fillet. Press the green tick to close that. And just for neatness, what I'll do is hold Control, select this red point, the origin, and also this bottom line. And then I can select midpoint, add relations, midpoint. So now it's locked into position and all the geometry is turned black, which means it's fully defined. So the sketch is finished. Let's close the sketch. And this time, rather than applying an extruded cut, we want to apply an extruded boss base. This time, there's a good chance that we'll automatically pick up the extruded thin feature for us. We don't actually have to tick this thin feature box. So what we'll do this time is we will change the value to 70 to make sure its overall height is 70. We'll change the thin feature itself to 1 millimeter. And we'll also just double check, and we're going to have to flip that inside as well. So flip the direction of the thin feature so it's inside. We want this to be the exact same shape as the previous groove. So press the green tick, and there we have the mesh before it's actually been drilled or have any holes cut in it. So what I'm going to do is start a sketch on this end face, and in the top corner I'm going to draw a hole. Now a note, I've drawn this a few times and I find that if you draw the holes very, very small, you're going to need significantly more of them to fill up the mesh. And it's going to be quite demanding on the computer, so you have to find a compromise between the number of holes that look realistic and the number of holes that will allow your computer to render it. So I've tried this already, and what works for me is if I dimension that circle to have a diameter of 3 mil and to be down 2 mil from the top, and that's it. Now I've snapped it onto the edge because I want my mesh to start at the edge. So let's close that sketch and go to Features, Extruded Cut, select the circle, and there we have it. I've cut a single circular hole into that edge. Now the problem arises when I try to pattern that circular hole, because I want that to go along this face, to turn that corner, to go along the front face, turn this corner, and then finally go along the far face. So the best way I found to do that is with a curve-driven pattern or a sketch-driven pattern. A curve-driven pattern in this case. So what I need to do is get a curve that maps perfectly the direction and the path of my pattern. So to do that, let's go to Sketch, change it to a 3D sketch, and select Convert Entities. That will allow me to pick up all of these edges all the way along there and turn those into a new sketch, but a usable sketch. Okay, we'll just try clicking those again. I accidentally deselected them. There we have it. So as long as you have the whole loop selected in one go, now you can press this green tick and it creates a new sketch, a black line, which is going to be the path for our pattern. So let's call up the pattern. We'll go to Features. We'll close the sketch first of all. We'll go to Features, Curve Driven Pattern. If it hasn't already selected the sketch, select it. Now in my case it already has. You can see up here in Direction 1, the 3D Sketch 1 has been selected. So under Features and Faces, I want to click the circular cut. Now it may be hard to click it here. In that case we'll press the drop down arrow up here and select Cut Extrude. And you can see it gives a preview, and there's a little bit of trial and error involved in getting the right spacing. Now I've worked out my maths and I want the spacing to be 4 millimeters. Let's see how that looks. Looks good. And the number of them, you can either calculate that or simply just press this up arrow until you get the number you're after. Now mine happens to have picked up the correct setting. Mine patterns, and as it takes the corner, the extrude cut also turns or takes the corner with it. If that is not the case for you, make sure that tangent to curve is selected. If you select a line to seed, what will happen is all those patterned instances will be in the same direction, same orientation as the original. So make sure you select tangent to curve. And let's add on one more, 96 of them in my case, and press the green tick. So if I wanted, I could now pattern all those holes straight down, but that's not the type of pattern I'm trying to simulate. I want to simulate a pattern that is staggered every second row. So let's start a sketch on that surface again. And I want to draw a circle in this approximate position. And dimension it to be the same size, 3 millimeters in diameter. And to position it correctly, what I will do is press the drop down arrow beside the line command and call up a center line and join a triangle, 3 lines between 3 of the center points of those 3 circles. Now if I hold Control and select all 3 lines, I should be able to add an equals constraint over here on the left. And that will mean it's perfectly positioned. The spacing should be even between all 3 holes. And let's repeat the procedure. We're going to do an extrude cut to remove that single hole and go to a curve driven pattern. We'll have to select the 3D sketch. Then we'll have to select the cut extrude we've just applied. And I see the arrow is going in the wrong direction, so it's not giving me the preview. So let's go over here and hit flip direction. It should keep the settings from the previous curve-driven pattern command. If not, you can also just change them again. So 96 is the number of instances in my case, and the spacing is 4. So press the green tick, and now I have the 2 different rows and the 2 different patterns, which in turn will be patterned down the way. So let's do that. That is not a curve-driven pattern. That's just a simple linear pattern. Now, we need to first of all give it a direction. So I'm going to select this box and pick a line going in the direction I want the pattern to appear. In this case, it's this line. You can see it's only actually picked up one of the patterns. So down here in Features and Faces, click into that box and make sure it's got both my patterns. In my case, it's Circular Pattern 1 and Circular Pattern 2. So you can see the spacing is a little off. So what you have to do is try to get the proper spacing. You can see as I change the spacing here, it gets bigger and smaller. So I've experimented a little with that, and I'm going to put in spacing of 6.5. And you can see it looks okay. And I need 8, 9, 10 of them. In fact, I might even put in 11. In fact, what I'll do is I'll leave it at 10, but I'll change this to 6.55. or even 6.7. Might be too much. No, that works. So when you're happy with that, press the green tick and wait. So depending on your computer, this may take a few minutes to render, but I've never had a crash here. It tended to always work for me, so give it the time it takes to render. And there you have it. The model itself will rotate quite freely and quite easily, but every time you go back in and edit that pattern or edit a feature, you will have to wait for the render time. For example, I want to edit this so the spacing is a little more, so those holes go down to the bottom. So if I edit the linear pattern, and let's say my spacing now is going to be 6.75, and press the green tick. See, I still have to wait a few moments for it to render. And there you have it. So here we see the mesh after it has been rendered. It looks quite realistic. And remember, the procedure that I used there is just as applicable if you're trying to get more complicated curved meshes. Here you can see, to speed up the procedure, I've used slightly larger holes, and depending on your machine, as I said earlier, you can use more smaller holes if you want, but it will slow down the machine. You have to find that right balance for yourself. So after the assembly has been created, that's what it looks like. The green icon there, just out of interest, there is a material appearance called LED, and instead of setting something to plastic or steel, for instance, if you set a body or a part to have the appearance of LED, you'll get that nice realistic looking glow. So thanks for watching. If you found those useful, why not visit our GMIT Letterfrack YouTube channel for more, and we look forward to talking to you again soon.